Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leonard Fakinati. Let's write some code together, shall we? What we have on the menu today is what we have always had on the menu forever. It's the Waveforms display. In case you're new here, we are developing real-time audio effects for REAPER. We are focusing on the visuals. We are focusing on drawing what the effect is going to do to the audio, to the extent that it makes sense. And a fundamental thing of this endeavor is to show the waveform, to show the audio as it's coming through. As it turns out, this is a deep rabbit hole, and we have been there for months now. I think we are seeing the light, and we'll get there soon. So what we have on the menu today is to revisit the implementation, fixing some mistakes, streamlining some things, simplifying some things, and essentially just discarding ideas that didn't pan out. So we are going to revisit the whole thing from the top again. I guess the best place to start is the effect that I used to even test. I have this effect that doesn't do anything to the audio, it just plots the waveform. And we are going to revisit this because it shows how the waveform display is used. So we are developing this library, and this is using the library. So let's go over what we have here. We have a slider for scaling. We haven't implemented scaling yet. Well, we have implemented it a couple times, but in the current incarnation, scaling is not working, so we have to do that. Maybe we will do that today if we are lucky. But then we have this other idea of plotting a picture so that we could test that the thing was transparent, and I think that much is settled, so we can remove this. This is as important in the library. Then we can get rid of all of that. And this refresh rate is no longer true because we determined on Monday, we ran some tests and determined that 60 frames a second is not something the REAPER can hold, at least not on my machine with my setup. So I suppose that most machines will not handle it. So we are going to go with 30 frames per second, which is not ideal, but it's better to have a steady frame rate than a very fast one, which varies. Then we just create one waveform display per channel, even though we are not actually plotting all of this, but so it is. And then we have this call to the waveform new, which is going to get as arguments the width and height and the duration in milliseconds. So this width and height is of the off-screen canvas to which we draw to, not the actual drawing of the waveform you will end up seeing on the screen. Great. And this is the duration in milliseconds. So it's going to be 5,000 milliseconds or 5 seconds worth of audio that it will try to display on the screen. Here, I think that there is already something that we will want to simplify. The thing is, we are asking for the duration in milliseconds so that we can store that duration in milliseconds and in samples. The duration in samples is used to compute where things are going to go on the screen, and the duration in milliseconds is used to compute the scrolling of the waveform across the screen. But, and I wish I had the effect in a working state so I could show what it looked like, but we broke it last time. I didn't fix it, so it's still broken. I cannot really show what's going on, but in essence, it is just a matter of this one. Yeah, it's just a matter of doing this. So our effect is supposed to do something like this, where it scrolls across the screen and updates the waveform like this. So we have two variables. One is the duration in milliseconds, the other is the duration in samples. The duration in samples is used to compute the actual shape, but the duration in milliseconds is just used for that scrolling effect that I just showed. But there are two ways to go about this, and the main issue is that there is the audio thread pushing samples into the waveform display data structure, and then there is the user interface thread reading those samples. And we need to synchronize these two activities. And currently the way that we are doing that is by looking at the clock. We use functions called time precise, or at least we used to use. I think we still use. Yes. We are relying on something called elapsed. Yes, this guy. And this may be why. This may be why the thing is broken right now. Yeah, because we removed this elapsed variable. Yeah, so we are looking at the clock to see how many samples we should plot at any given frame. And that's one way of going about this, one way of dealing with this concurrency between the audio thread and the user interface thread. But another way of doing it is with simply counting samples, because it may be the case that frames are being dropped left, right, and center on the user interface thread, but the audio thread is not supposed to be glitching out. Under normal circumstances, under normal operation, the audio thread is going to be called 48,000 times a second. So we can just look at them. We can just look at the samples, or we can look at how many samples have been processed so far, and we can determine the time. We don't have to look at the clock. We don't have to use this variable. We played around with using this variable, and it didn't make anything smoother. It doesn't help. So because it doesn't help, we might as well not have this notion of time and just do the simple counting of samples, and that should be good enough. That should be as fast as we can make it, because it's one less thing to do. It's not looking at the clock. And in spirit, it's similar to what we did on Monday, in which we translated some piece of code that was based on time, and we wrote it so that it's based on counting, or counting samples, or counting the number of times that the user interface thread has been called. In other words, counting the number of frames that have been rendered. So we are just dealing with counters, and they are supposedly faster than looking at the clock. So that's the intent. And because we don't look at the clock, and we will not be looking at the clock anymore, we don't need to store the duration in samples, which means that we can, duration in milliseconds, which means that we can just pass the duration in samples as argument here. And that's what we will end up actually using. Great. Then the serialized block is not interesting. This is a new requirement of using the library so that we can detect whether the audio thread is running from the user interface thread and vice versa, which is helpful in many ways. For instance, here on the sample block, we detect whether the user interface thread is running, and only if it's running, we trouble ourselves with pushing samples into the waveform display. Otherwise, we save this work. And we were able to see on Monday that this works. This saves some CPU. When the effect has the user interface open, the effect was taking like 0.1% CPU. When the user interface was closed, it wasn't taking any CPU. It was at 0%, because then the sample block is essentially empty. There's a bit of preamble here, but it's just a counter, so it's essentially doing nothing. Then this is, again, just preamble. It's necessary to use the library, much like this thing. Then we set a background color. That's all right. Then this was testing transparency stuff. it's okay for us to remove this. And then this is showing the frames per second, which I do want to keep. And this is some tentative drawings of the waveforms. And we are probably going to have to revisit these arguments, but they'll be here for now. Why? So now let's go over the implementation of the waveform. So that so far was the use. Now let's go to the implementation. And let's revisit what we have here, making the changes along the way. What is this? Size in frames. And what is this used for? Okay, I get it. So this is a constant that will be used there, and it determines the size of the circular, or it helps determine, it's part of the determination of the size of the circular buffer that is used to communicate between the audio thread and the user interface thread. The meaning of this circular buffer is about to change. So this may or may not be relevant moving forward. Let's start with this constant may or may not be relevant moving forward. Let's start by renaming this, because currently, and that's, I guess, the title of the stream. Currently, the way that the waveform display works is on the sample block, when we push a sample into the waveform display, it simply stores that. When you push a sample into the waveform display, it simply stores that into the circular buffer. Then it's the job of the drawing function to go over that circular buffer and collect samples and then draw. And when doing the drawing, this point in time, for instance, this one point in time where the cursor is, this is 1 pixel, but it represents more than one sample. So we need to fold down the samples into what I'm calling columns or slices. So the work of going over the samples and computing the slices or the columns relies right now on the user interface thread. And that may be too much work for us to ask from the user interface thread. After all, we are sort of asking the user interface thread to do to some extent, some audio processing. And that's where the title of the stream comes in. We could distribute this work a little bit more fairly, I think. And this is something we have tried before in one of the incarnations, but there were many other reasons why it didn't pan out. But the idea here is we are going to do this computation of samples into slices on the audio thread, and that's what we are going to collect into the circular buffer. And that is going to alleviate some of the work from the user interface thread. But now the thing that tipped the scale for me and then made a difference and that made me decide to pursue this route is that over here we now have this new functionality that we implemented a couple of days ago that saves this work if the user interface is closed. So we are not doing a lot of work on the audio thread unless we really have to. And this distribution of work, I think, makes a lot more sense. Right. And it has to be the case that some work it needs to happen on the audio thread because that's the thread that has access to the audio. So we might as well just compute the maximum and the minimum there. So what I'm saying essentially is that we will have a waveform, and it's not going to be samples, it's going to be columns, or maybe slices. I guess I'll call it slices this time. And then a slice is just this, it's where the cursor is. It's one thin line that is going to make up the waveform. And that's going to be a circular buffer. So that will be the circular buffer used to communicate between the user interface thread and the audio thread. The audio thread is going to be writing slices into the circular buffer, and the user interface thread is going to be reading slices and plotting the slices and copying the slices into a temporary, not a temporary, but an auxiliary off-screen buffer, a separate canvas. We'll get there. So there is this thing that the audio thread is writing into the slices circular buffer, and the user interface is reading from that. But we don't know how much to read on the user interface thread. So that's why we keep this separate index, this read index. Typically, the way that you access a circular buffer is in an offset based from the write head, and the write head is managed by the circular buffer itself. But in this case, we want to read separately. We want to catch up to the write head. So that's why we'll have a slices read index, and that's going to be part 1 of the data structure. But there is something else. When we are doing this folding of samples into slices, we need to know how many samples we have gone through already and what is the current maximum and minimum. Each slice is determined by a maximum and minimum, the top where the slice should start and the bottom where the slice should end. So what we are going to do is to have slices samples, and that's how many samples have already been collected in the current slice, and also maximum and minimum. And I think that that's pretty straightforward. It's just the maximum and the minimum of the sample that we are constructing. And with these 3 pieces of data, we have what we need to populate the slices. Well, not quite. There's still some more things that we need to consider. We need to consider how many samples are going to go in each slice. So I guess I will put it here. Waveform, slices, and samples per slice. This naturally will be determined by the duration as well as the width. We'll get to that. So we are ready to test this and that. We haven't gone through this yet. The duration in milliseconds and the duration in samples. I don't think we actually need to store all of this, because the duration in samples will be used to compute the samples per slice, and that's that. Let's confirm that this is the case. Yeah, the only reason why we store all of this is to compute the number of samples per column. So, and I'm not really sure why I had to do it here. It doesn't make a lot of sense to me right now, but maybe it made sense back then. But yeah, I don't think we need to store the duration at all, because we have already computed the number of samples per slice. Then this samples maximum and minimum we have covered here. Those variables are necessary to compute a slice. And then there are these things related to drawing into the image. So samples come into the audio thread. We compute the slices. We store the slices here on this circular buffer. Then the user interface thread comes in, reads the slices, writes the slices into an off-screen image, and then blitz that image onto the frame buffer that you actually see, the user interface that you actually see in the effect. So this first intermediary between the audio thread and user interface thread we have already covered. Now we need to cover the second step, where we take these slices and we draw them into an off-screen canvas. So let's look at the variables that we'll need for that. well, we will need an off-screen canvas itself. We'll need the handler for that resource. And I guess I can call that the image. And it does stand to reason that I will need to know the image width and height. And these names are good, so I'm going to keep them. Then when drawing the contour, so the waveform has a shape, and in REAPER, it doesn't seem like the waveform has a contour. But in our version, I think it would be nice to have a contour delineating the waveform. For that, we need to draw a line between the previous column and the current one. And that's what this is. Yeah, that's what these three variables are. Except that now I'm calling them slice. And well, to be honest, I don't really need to store this now. This information is readily available here. Yeah, there you go. I don't need this anymore. But I will need this. Yeah, so this right index is the place in this temporary image, this off-screen canvas that we are drawing the waveform to. We have a right index saying where we are in that writing process. You can think of that image as a kind of a circular buffer, except that I'm realizing it as a temporary image because I think it saves resources to do it that way, because I'm not calling the primitives to draw so many times. I'm just drawing the new things and bleeding what was already there. So I'm sort of using this image as a sort of a temporary, as a sort of a circular buffer. So that's why I need to manage the right index. I think that's all I'm going to need. So let's number these parts of the data structure. And then I'm still not sure if I'm going to need this. I don't think I will need this. Yeah, I will remove this for now. So there you have it. That's going to be our data structure. Now, when we create a new waveform, it is the duration in samples only. The duration is given in samples. See? When I create a new one, I give the duration in samples. Then I create a waveform local variable that I return in the end. The data structure has 10 parts to it from 0 to 9. Then we need to initialize all of these guys. How do we initialize these slices? They are a circular buffer, so it will be something like this. And what is the size of this circular buffer? The beauty is that now the size is not dependent on these variables anymore. The size is not dependent on the sample rate. The size is only, well, I guess it is. The purpose of this is to communicate between the audio thread and the user interface thread. So the size needs to be at least the ratio with which the audio thread is called with respect to the user interface thread. But I think that something like, I think that something like 300 will do. Because let's think about how often the audio thread is called. It's called like at most something like this, and at least something like this. many times per second. And the user interface thread is called about 30 times, up to 60 times. Oh, but it's not only that. It's also the case that we are already collapsing samples into slices. So yeah, 300 slices is enough, I'm going to claim. Probably it's enough. If we start seeing glitches, then we need to increase this number, and we could get away with decreasing this number, but really a circle buffer of 300 position is cheap. I will not worry about it. If 300 samples does it, I will be happy. And think about it this way. This could only glitch if from one call to the user interface thread to the next, we would have to jump 300 pixels. That's a lot. That's a big jump. So even if lots of frames are being dropped, jumping 300 pixels is probably too much. So 300 should be enough. Now, how many samples do I have on each slice? Well, let's think about it this way. I guess the formula is going to be something similar to what we have below, but let's reason about this from first principles, because it should be relatively straightforward. So I want to take, how many samples? I want to take duration samples. So duration is the quantity, and this is the unit of measurement. So I want to take duration samples to go over width pixels. Or I guess the width is the number of slices. So this is given in slices. Then I am interested in knowing how many samples do I have per slice. I guess I just divide one by the other. If I take the duration and divide by the width, I will have a number that is in samples divided by slice, so in samples per slice. And that's that. Let's see if this makes sense from an intuitive perspective. Let's say that the duration is 5 seconds, and that is 5 times 48,000. So $240,000. And I want that time slot, that duration, to occupy 768 slices. So if I just divide one by the other, there will be 300 samples on each slice, or about 300 samples on each slice. That's a number that makes sense to me. It's a reasonable number. It would not be reasonable if this number was much lower, because, or even if it was between 0 and 1 or negative or something like that. This is a reasonable number. We have 300 samples on each pixel on the screen. Yeah, so I think that this formula is right. Then moving forward, how many samples do I have in the current slice? 0. What is the maximum? It is infinity, or minus infinity, I suppose. The maximum is minus infinity, and the minimum is infinity. Great. Then I will have the read index. The read index is at 0. It starts at 0 because this circular buffer will start with a write index at 0 as well. Then this image, I think I just allocate a new one. And the width and the height are the width and height given to me as arguments. And then the right index is also 0 for the same reason this right index starts at 0 as well. Then let's see, we covered this and that and this and those and that and that and this and that and that and that and that, and we covered everything. All right, we're making progress. Next, let's look at what happens when you push a sample into the waveform data structure. It will not be as simple as just pushing into the circular buffer. No, it will not be as simple as that. I do know that when pushing stuff into other stuff, I do like to return the thing that was pushed. It's a convenience kind of thing. If you want to push and then assign this to something, which is not the case, but you could assign this to a variable like this, and then this would be the sample. So it is kind of convenient. So I'm going to start with that. But now let's go into the logic. What will I need to do some pushing into the circular buffer? Well, I will need to collect some parts of the data structure. Which parts? I think that these parts, or maybe not even that one. I think that this will do. So far, so good. Now, oh, I forgot semicolons at the end of the lines. Now we need to perform a logic that is similar to what we have here below. First, let's collect the sample into the slices maximum and minimum. And the way we can do that is by updating these variables and taking the maximum and the minimum between what's already there and the sample that came in. So this way we are just collecting the sample into the current maximum and minimum that we have going on. Next, we have to check, well, we have to increment this number of samples per slice because we just pushed the sample. So let's increment this. I forget if we can use the circular counter that way. We can. So we just need to give the circular counter and the maximum. And this is the circular counter. The maximum is the number of samples per slice. Oops, no, I have the wrong variable there. This should be slices samples. That's the counter of how many samples we have in the current slice. And the maximum is this. And then the step will be by default 1. So that's going to work out. Great. Then I want to know if I wrapped around, if I have collected enough samples. If so, I will do a bunch of things. So I just have to check if this is less than 1. 1 being the step of the circular counter. If this is less than 1, then I will have to do a bunch of things. Oh, I just realized something. A slice is a maximum and a minimum. So I will need two circular. I could just have one circular buffer and then try to work with data structures within that. It kind of works. We did this before on the stream, but it's cumbersome. So I'm going to instead just have a maximum and a minimum. And I will need to naturally renumber all these guys. And I think that maybe this is okay and this is okay, but this is not okay because this is not the maximum of the slices. It's of one particular slice. So I guess I will rename slices maximum into slice maximum. And this I will rename like that. And then also this is about the current slice. Maybe even that. Okay, let's review the names. So we have the circular buffers, they're called slices. Oh, I made a mistake. I meant to do this. Okay, so let's review now. We have two circular buffers. They're called slices maximum and minimum. Then for each slice, we have the maximum number of samples that we want to. I guess I will reorder these two fields. So we have how many samples are already collected in the current slice, the maximum number of samples that I will want to collect, then the current maximum and minimum. And then we'll have a read index into those two circular buffers. And these are the image stuff. Great. So now we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. And then we need to start the circular buffers for the slices. Just like that. Then I reordered these two fields. And I didn't change anything else, so it should be good. Then here I reordered these two fields. And then, okay, I think I'm back into a good stage. So let's review what we have here. We are just getting a hold of the slices, the samples in the current slice, the maximum number of samples, the maximum and the minimum. Great. Then we update this number. And then we check if we are about to wrap. So if we are about to wrap, then I will need to push into these two circular buffers for maximum and minimum. In fact, this doesn't exist anymore. Yeah, now this is one thing that I'm doing now is I'm selecting this, because when I select, Visual Studio Code highlights the other occurrence, and that helps me catch typos and that sort of mistake. It seems like we are good. Okay, so with that, we have the circular buffers. We can push into the circular buffers. And what we push is the maximum and the minimum that we have so far. Then we'll need to reset these guys in pretty much the same way we have reset them here. The maximum is now minus infinity and the minimum is infinity. Anything else that we may need to update? I don't think so. We have already updated the counter. Yeah, we just push and reset just like this. And then at the end here, we need to update into the data structure the parts that we changed. So let's copy and paste this. Let's find all the equal signs. And let's go over what may have changed. The maximum and the minimum may have changed. The number of samples has changed right there. The maximum doesn't change. Oh, these two don't change. They are the addresses of the circular buffers, but we already updated them here. So the only things that we assign to are these three variables. And there they are. Yeah, I think that this is all correct. I like the way that this reads. So let's move on to the drawing function. It's going to receive as arguments the waveform data structure, the x and y position, the width and the height that I want to draw to. It's not the same as the temporary image. The temporary image has a fixed size that was determined on the creation of the waveform display or the waveform data structure. Then whether you want to square root the, oh, interesting. I can just take the square root. In fact, that's what I already do. I can just take the square root of the maximum and the minimum and it should be good. So yeah, it's fine to have this here. Whether you want to scroll, whether you want to erase on wrap, which is only relevant when you're not scrolling. What is the fill color and alpha? What is the stroke color and alpha? And what is the cursor width color and alpha? Okay. Then I will want to use some of these, but not all of them. The logic here will change a lot, so I guess I would just remove all of this. And up to this point in the function, I'm just fetching pieces of the waveform data structure, so I might as well go back there. Because many parts of the data structure have been touched. I have renamed them or something, so might as well just grab them again. And let's see the ones that we are actually going to need. So the slices, maximum and minimum, we are going to need. This is all about computing a single slice, so we don't need it from here. This is about reading the slices, and this is all about drawing, so we'll need all of those. So let's add them as local variables. And I will also kind of jump the gun here and do the other part, which is writing. So the converse of this. What will change? These are the addresses to the circular buffers, they don't change. The read index will change. The image address will not, the width and the height will not, but the write index will change. So now we have already read and we have written what we'll need to read and write. Then let's go over this and find the bits and pieces that make sense to move up. The number of samples per column is no longer relevant. That has been taken care of. The image height midpoint will be used for other computations, so this makes sense to move. Then we are setting the image dimensions. That's just preparing the image to use, so that makes sense. We could go about this differently. Currently, the way that we go about this is we allocate an image right in the allocation, but we are not able to do this part during the allocation because during the allocation, which happens on the init block, we don't have access to this function that does the allocation of the canvas for the image. We allocate the address and we allocate the image in different positions, in different locations. So what if instead we did this? I kind of like this approach where we start with an image that is undefined because we are not able to allocate this from here. And then we check, is it undefined? In other words, do I need to allocate this? And now I can, if I need. And then I allocate. And then it works. Yeah, I like this. So in principle, this is sort of allocation, so I'll keep it there. And then this makes sense. And then we are about to draw to the off-screen canvas. This is how we do it. We change the destination so that the drawing happens into the image now. Then this is a facility that we implemented last week and we revisited it on Monday. So this is something that tells you the GFX block was not running. Maybe the effect was closed. And we just opened it. The user interface is just starting to draw. So in that case, we want to reset a bunch of things. I'm going to copy the whole block, and then we can revisit the parts. Oh, yeah, so if we are just resetting the screen, or if the effect is bypassed, interestingly enough, if an effect is bypassed, it's not processing audio, but the user interface is still showing up. And in that case, what we can do is reset the whole thing. Yeah, I think it makes sense. We just reset the whole screen. And the way we do that is by resetting a bunch of these variables. So this read index is now no longer necessary. Then this image column in samples, maximum, minimum, previous, top and bottom, all of these can go away. The write index we need to reset, and then we reset the image. yeah, from 0, 0 up to image width and height, we multiply by 0. So we reset the image. And we need to reset anything else. We have the maximum, the minimum, the read index, the image, width and height, and right index. No, we have reset the right index, and that's all we need. Great. Next, we have this notion of how many samples to read. That has to do with the passing of time. We are no longer doing that business. But it could be nice to have a milliseconds to seconds and vice versa. So I will do this. I will put this there. And there you have it. Then this part is implementing that whole logic that we have implemented above, where we take the maximum and the minimum, the circular counter and whatnot. So we are going to transfer this up, but only the pieces that are necessary. So at this point, we have already reset the image if we think that resetting the image is necessary. So we are ready to do the catching up. We have a read index into the circular buffers, these two circular buffers. We have a read index, and the read index needs to catch up with the write index. And this is how we can do it. We have a while loop, and the condition is just this, I think. But the index is probably called something else now. It's the slices read index. If it's not the same as the samples write index, well, now it's not the samples write index, it's this guy. I will need to create a variable. I'll call this the slices write index. And the slices write index will be either one, it doesn't matter, they are always in sync, or at least they should be. But just in case, I will take this second one, in case there is a write in the middle of happening. So this one will be written to first, and this one will be written to second, so it's safer to use the second one. And then, what is the index that I want? I want circular buffer write index. And that's the write index of the circular buffers. Great. But it's not called the samples write index, it's the slices write index. So this is now going to catch up. Oh, I also will need this line. This one right here. And there you go. I think that this setup does it. What we have is a read index that is moving forward, and it's trying to catch up to the write index, so that if they are the same, I stop. Great. So we have taken care of the whole while loop setup, and this we don't really need anymore. Then we need to actually read from the circular buffers. Right now we have the maximum and the minimum situation here. We are no longer doing that computation here, but we do need to get stuff from these two guys. So I guess it will come in here where I have a slice, maximum, and minimum. And these variables will be oh, I don't need to do a gash into the circular buffer because that would be with an offset based on the write index. I will just read slices at maximum and minimum at position read index. Just like that. Great. So now I have the maximum and the minimum. I can get read of a bunch of things. yeah, let's start by, let's do the square rooting because that part is easy. So if you want to square root, then we rewrite the maximum using this formula and rewrite the minimum using this formula. We are just essentially taking the square root, but we take the absolute value because the square root of negative numbers will not make you happy. And then we multiply by the sign of the original number so that the sign is preserved. So we are taking the square root, but we are preserving the sign. If the parameter is negative, the return value is undefined. Great. All right, so we are taking the square root. All right, that is working. And then we are going to, oh, so I can remove this. And then we have this computation that will be the top and bottom based on the maximum and minimum. Yeah, so I guess what I can do is just essentially come here and rename everything that is named column. Now we are naming slice. Maybe I should have done this before, I don't know. But we'll have a bunch of local variables that we'll be defining. So I'll not just cut and paste because we'll have to also update this list of local variables. So let's do this in steps. Let's do the parts that are easy, like stuff we can remove. So this samples read index. Oh yeah, that's what we should be doing. We are doing the wrong thing here. Should be doing that. And instead of samples, slices. And instead of... Yeah, no, I think we need a slices length situation here. So besides the right index, we'll also grab the length. Length and right index. Length and right index. And then the length will be used there. And that's the correct way of... If we were just adding one, it would go indefinitely to the right. No, we want it to wrap back around, just like the right index does. So now this is better. Great. And then we can remove it from there. Let's see what else still makes sense in here. This is about computing the slice. We have dealt with this already. This has to do with let's see. About here, we will need to introduce code that will actually draw stuff. So let's grab from here the code that we'll need. We'll need to compute the coordinates. So I guess I can start with that. Actually, most of this is making sense to me, so I'll copy everything above and we'll revisit this in place already. So we'll introduce slice X, top, bottom, Y, and height. All of these are new variables. And they all come after a slice minimum. Now let's actually look at the formulas to see if they make sense. Here. So the X position of the slice into the image is just the image right index. That makes sense. We will update the right index down here. Yeah, right. Okay. Then the top is just the midpoint minus... Oh, we have an image slice going on here. We can rename that, and it will be closer to the code that we currently have. So we have a slice maximum and a slice minimum. Okay, this makes sense. Yeah, all of this makes sense. Then we are erasing what was there on the temporary image by using this. So we go to the position X, position Y is 0, the width is 1, the image height, and multiply by a bunch of zeros. That erases the thing. Then we set the color, we set the alpha, we draw a rectangle of width 1, height given by this, and the positions that we already computed above. All of this checks out. Then we are about to draw the stroke. I'm going to not do this right now. I'm going to comment out this stroke. But let's deal with the right index. The right index needs to be incremented. It's just a circular counter with image width. That's great. Then if it's less than 1, it means that we wrapped around and we are not scrolling, and I want to erase on wrap, so I do this, which erases the image, which is the same we did above. See, it's highlighted in blue because it's the same line. Great. And this updates the read index. I guess I want to update the read index first and then this. Guys, I will do it like this, where I update the read index in a way of saying I am done with reading. I'm about to write instead. Okay. And then we have some more stuff going on here for actually bleeding. So far we have drawn to a temporary image that is off canvas. Now let's split that back into the main canvas. And the way we can do that is, I think that all of this code is just going to work out. Let's paste it there and review. And then this code is stale. This is the old version of writing stuff into the data structure. Okay, so this has to do with computing coordinates. This has to do with resetting. And this has to do with drawing. So all of this block, this whole block, as I'll separate it. Okay. And then if we are scrolling, we're bleeding the image, then all of these coordinates still hold. Yeah, everything makes sense. Let's commit and then start debugging. As usual, on our first try, nothing shows up. Oh, something showed up. That's not typical. Usually nothing shows up. And what is showing up is quite odd. It's bursts of stuff. But at least I would say that this stuff is scrolling by as smoothly as we are able to make it. So all the simplifications we introduced and everything, it is what it is. It's as fast as we can make it. And the frame rate seems to be steady. And that's good news. Okay. You know what? I'm so happy that this actually drew anything at all on the screen. And I think I'm going to call it a day. Tomorrow I'll be back here and we'll debug this and go over everything that is in here and find where the issue is. But at least we are back into a state where we have something on the screen. And just to make sure that the purpose of today's stream was so that we would be distributing the work. Now the audio thread is doing some of the work, but it's only doing some of the work when work needs to be done, when the user interface is open. When it's closed, we see 0 CPU. When it's open, yeah, it's going to take a little bit of CPU, and that's all right, because it's doing some work. Great. I claim that this was a success, and I see you back here tomorrow. Thanks for watching. Thanks for being here. Hope you were enjoying this. I see you back here tomorrow, and we'll be debugging this, trying to get it to work. It will be fun. Hopefully we are reaching the finish line here. All right, see you tomorrow. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.